Okay, so in this PowerPoint we're going to just go through the whole area of stairs, mainly focusing on the functions of stairs, the styles of stairs, the terminology involved, and how the stairs are constructed. And by gaining an understanding of all these things, it will help in understanding and carrying out the drawing details that are involved. Some of the functions of stairs first. Some obvious things, but just to put in words: to provide easy, safe walking access between one floor and the next, to have a sufficient strength to accept any loads that it may be subjected to resist fire for a sufficient length of time, to allow the occupants of the building to escape. So it's all pretty obvious stuff there, but it's important to be able to put that on paper as well. So, styles of stairs that we're going to look at here, they're just basically the design of stairs, what they look like and so on. A straight flight stairs, first of all. A straight flight stairs has no twists or turns. It rises from one floor to another in a straight line. There are a maximum of 16 steps in a flight. A straight flight stair is simply the most simple and basic standard type of stairs that you would see. This here shows what that looks like in architectural plans of a straight flight stairs. This here shows a 3D model of the straight flight stairs, and a photograph of the straight flight stairs, which we're all familiar with, I'm sure, is just there. Half-turn stairs. Half-turn stairs have a landing with 2 flights. Each flight has a maximum of 16 steps. When you walk up the stairs, you do a U-turn on the landing between flights. Again, quite common to see. A half-turn stairs in architectural plans would look something like this. There's a 3D model of the half-turn stairs, and there's a photograph of half-turn stairs. Again, I'm sure most people have seen something like that before. Quarter-turn stairs. The flights are at 90 degrees to each other with a landing between the flights. There is a maximum number of 16 steps on each flight. Once again, quite common to see. That's how it looks on an architectural plan. That's a 3D model of a quarter-turn stairs. And we can understand from there. Spiral staircase. A spiral staircase is used where space is limited and sometimes for aesthetic effect. The steps wind around a central axis. The spiral staircase is something like this. I'm sure people have seen it before. On the left hand side, that is what it would look like in an architectural set of plans. So they're the main stair styles. Now we're going to go on to stair terminology. So stair terminology, we're going to look at the parts of the stairs, how they're constructed and so on. So the first 3 terms we're going to look at the wording of the 3 terms, and we're going to look at a diagram to help us understand those. So the flight, okay, I'm sure people have heard of a flight of stairs. A flight is a continuous set of steps from one floor to another floor or to a landing. That's a flight of steps is essentially a set of steps. The stairwell is a space occupied by the stairs. The landing is a platform between 2 flights to serve as a rest, also used to change the direction of the stairs. Again, I'm sure people have heard those 3 terms before. To get a better understanding, we have a diagram here, and the flight is basically here. It's the set of steps. The landing is up here on top, which you can see there, and the stairwell is just the whole space where the stairs are fitted into. It's called the stairwell. So more terminology. People will be less familiar with these terms, but again, our diagram is going to help us understand. The tread. This is the horizontal member of a step that you walk on or tread on. You may have heard before people saying to tread on something is to walk on something. So the tread is essentially the piece of wood or the horizontal member that you step on. The riser. This is the vertical member of a step that goes from one tread to the next. So the riser is what goes underneath the tread, supporting the tread above and the tread below. Step. This is a combination of one riser and one tread. It is housed into the string. Okay, again, so basically the step is a combination of this and this. So the tread is the horizontal member, the riser is the vertical member, the step is both of those together. Now, the string. This is the inclined member that runs up both sides of the stairs. The steps are housed into it, and it is housed into the newel posts. If it is against a wall, it can be bolted to the wall. This will become more clear when we look at a diagram, but essentially the string is the wooden member that goes from the bottom of the stairs up to the top along the side that all the steps are housed into. The nosing, this is the rounded part of the tread that protrudes past the face of the riser below. These will become more clear again, as I said, once we show a diagram. Now, what we have here is a step. Okay, this wooden member here, as we said, is the tread of the step. This wooden member here, the vertical one, is the riser of the step. The nosing is the round part that sticks out of the step, so here and here. Every single step basically has a riser and a tread, riser and a tread, riser, and so on. You can see there's a little housing joint, so the riser is housed into the tread, so there's a slot in the tread that the riser slots into, so there's quite a bit of craftsmanship involved there in making those stairs. The string is basically this wooden member that runs the full length up the side of the stairs that those steps are housed into. Again, that'll become more clear in more diagrams. This set of stairs, I suppose, can show us that in more in 3D. This wooden member is our string. The nosing is the bit that sticks out. This flat bit here is the tread, and this vertical piece here is the riser. So we've got a riser, a tread, riser, a tread. And we know that this tread is housed in with a housing joint at this point and down here to the riser. And that continues all the way up the steps. Okay, now this diagram here, we can see the tread, the riser, the tread, the riser, and the tread. There's two terms involved with these now. So the tread and the riser are the actual pieces of wood. We've got two more terms. One is called the rise and one is called the going. Right? The rise, I'm going to read this first. This is the distance from the top of one tread to the top of the next. It must not exceed 220. So the rise is basically this height here. Right? So from the top of this tread to the top of the next tread, the top of this tread to the top of the next tread, that is known as the rise. The riser is the piece of wood, the rise is that there. With standard regulation, the rise must be between 170 and 180. If it's less than 170, the rise is deemed to be too small, and the step basically is too small. If it's more than 180, so if it's more than 220, it's considered to be too high, and I suppose a step that's too high can be considered to be dangerous. Now, the going is basically the distance, essentially the distance of the tread. This is the horizontal distance from the face of one riser to the face of the next. It must not be less than 220. So, basically to explain that then, the going is the distance from the face of one riser to the face of the next. This diagram is showing it from the front of the nosing to the front of that nosing there, but it's essentially the same distance. So this distance across there is called the going. If the going is less than 220, the step is not deemed to be big enough. So the going must be at least 220 to, I suppose, allow a standard size foot step on the step. So, just to recap, this vertical piece of wood is the riser, this horizontal piece of wood is the tread, this distance is the rise, and this distance is the going. And stair makers and manufacturers and designers have to take into consideration these general sizes when designing their stairs to meet safety regulations. Now, moving forward, glue blocks and wedges. These are there essentially to improve on the stability of the stairs. Glue blocks, these are triangular blocks stuck to the inside of each step. They provide extra support and help prevent the stairs from creaking. Wedges. When the steps are housed into the string, extra material is taken from the housing to accept wedges. These clamp the treads and risers and prevent shrinkage from affecting the stairs after installation. Again, this will all become more clear when we look at some diagrams. Right, so this member here, as we said before, is the string. This is the tread. This is the riser. This is a tread. You can see it's been taken apart here to help us understand, but we can see there's the housing joints that are fixing into place. A lot of the work is done on the inside of the string, so a lot of router work is done. A lot of slots are taken out of this to allow these members to be housed or slotted into place, but there's also space for these wedges to be hammered up underneath each tread to tighten those into place. That will become more clear again in these diagrams. This is a view from underneath the steps. All right, what we have here, here, and here on each step are your glue blocks. They're essentially triangular blocks that are just hammered or are fixed and glued underneath the step to add stability there to the step, to stop it from creaking or moving in any way. You can see also these are the wedges which have been hammered into place to give it, once again, give it stability. The newel post, this is the chunky member at the end of a flight of stairs. The string and handrail are generally housed into it. The handrail, this acts as a guardrail and also gives assistance in ascending and descending a stairs. It is always parallel to the string. Diagrams will help us understand these. I'm sure people know what we're talking about here. That's a string. That there is the newel post. And that there is the handrail. Okay, the newel post is basically the large post, the string and the handrail are slotted into. The handrail is what you put your hand on as you walk up or down the stairs. That diagram there we can see once again the string, the newel post and the handrail. Right, newel posts take various different shapes and sizes. There's always a newel post on the bottom and there'll be a newel post up on the top as well. Your handrail again often takes different designs and shapes, and the string, as we said, is what's holding the treads and risers in place. The balustrade and the balusters, let's explain these. The balustrade, this is all of the framework between the handrail and the string, solid or open. Balusters, these are vertical members between the string and handrail. They are usually square or turned in section. They must be no more than 100 millimeters apart. Again, diagrams will help us explain this. So each individual member here is known as a baluster. All right, we can see these are balusters. I'm sure people have seen these before. They take various different shapes and sizes. Each individual one is a baluster. The group altogether is known as a balustrade. So all of those together are the balustrade. Individually, they are the baluster. Pitch, this is the angle of the stairs makes with the floor. And the headroom is the vertical distance between the pitch line and any obstacle over the stairs. So your pitch is the angle of the stairs. 35 degrees is the optimum or the perfect angle for a set of stairs. That can vary obviously. And your headroom, that's the amount of headroom that, that's the headroom refers to this distance here. There needs to be adequate headroom to allow people walk up and down the stairs. Now, just a little bit more on the stair construction. So we just finished up with terminology. We've seen a good bit of the construction of a set of stairs there anyway, but the construction will help us understand that terminology again. So just the techniques involved, the steps are housed, glued and wedged into strings to form a rigid construction. Glue blocks are positioned under the steps to provide extra support and to prevent creaking. Stairs usually have one string fixed to a wall while the other string is supported at both ends by a newel post. That there we can see, we've explained that, we have all this work taken out and the treads and risers slot into there and the wedges are then hammered into place. That's the underside of a set of stairs. We have the treads, the risers, the triangular glue blocks. There's some extra glue blocks on this one here. And the wedges, you can see there's space there. The wedges are hammered in to kind of tighten up. So this is what it looks like when it's been manufactured in the factory, with all these slots taken out, and the treads and risers are housed into those with the wedges they're hammered in to tighten their position. That's a set of stairs just looking up underneath them. You can see the newel post again, just showing different angles. You can see the wedges and the glue blocks and so on. That just gives you a different perspective from underneath the stairs. More views from underneath the stairs. You've got your glue blocks, you've got your wedges. All these slots have been taken out so you can push those wedges into place. That just shows the wedges actually been hammered into place to tighten up the position of the risers and treads. That's an actual set of stairs that's been half constructed. You can see there's a wood turn newel post there. The balusters are yet to be put into place, but you can see the wedges in place, you can see the glue blocks in place, and so on. A closer view of those wedges that have been hammered in on both sides. I'm just going to point those positions out. Now, it's important to understand also that the string itself is fixed into the newel post by using a mortise and tenon joint, as shown here. The mortise and tenon joint basically has a part of the string sticking out that slots into the actual newel post itself. This type of string design is called cut string stairs. What we've looked at so far is when this string, this piece of wood is completely, hasn't been cut, it's completely full and it's gone all the way up. That's called a closed string. This is what's called an open string or a cut string stairs. It's important to understand that as well. So if you see a set of stairs like that where the string has been cut out and the balusters go straight down, that's known as a cut string stairs or an open string stairs. Okay. You can see there that's an open string stairs. What we've looked at so far is if you can imagine this string going straight up along there and that's all covered. It's closed essentially, that's a closed string stairs. That's just showing the handrail, which is also mortise and tenon into the newel post. And these last two slides basically show the drawing details that are asked in the Leaving Cert exam for a set of stairs. This diagram here shows the upper part of a stairs, the top of a stairs. It's got 1, 2, 3, 4 steps. You can see the wedges, the glue blocks, the risers, the treads. You can see the housing joints. You can see the balusters, the handrail, the newel post, and this is the upstairs landing. These are the joists, and you've got the strutting holding that into place. So that is a drawing detail of the top of the stairs. And this is the drawing detail for the bottom of the stairs. Again, 1, 2, 3, 4 steps. You've got the wedges, glue blocks, balusters, newel post, handrail, etc. And it shows also the optimum pitch is 35 degrees.